Urbit from the outside in. Urbit is a reimagining of a computer, personal computer, that is based around the idea of it being permanent and transactional and primarily just a piece of data. So it's a very data-oriented approach to computing. The idea is basically that everything stored in your personal computer can be accessed as basically a file, and so it's at any given time, right? Then there's a program that's updating it, that's running it as an agent on your behalf, but at any given time, it's a file that stores a bunch of data in it. Think of it sort of like an Excel file, like Microsoft Excel, right? Where it's just this piece of data. You can open it up, and if you have a program that knows how to read that file, and that program can also know how to serve a user interface to you that lets you modify that file, right? So Microsoft Excel, here is the program. You might have a .excel file that you can open up with the Microsoft Excel program, and then once that program presents all kinds of commands that you can run to add rows add rows and columns and change the colors and things like that. Urbit's a little bit different from an Excel file, mostly because it is also designed to run continuously and to be what's called a server, which means that it's something that runs on your behalf all the time, and other people can send you things, can send you pieces of data at any time, and this program will hear those and store them for you. And you can also have it set up to actively go and send messages to other people, for you in an automated fashion. So, depending on if you want, that's sort of not default behavior, but if you wanted to set up sort of if this then that style kind of interaction among all of your social apps, or periodically update some sort of backup for you, things like that, then your Urbit is capable of doing that. And eventually we see Urbit as pretty much the only thing that you need for personal computing. That's really the goal, is that especially all of the rules that govern your personal computing. So things like who's allowed to send you a message? How do you know it's actually from them? Right? How is it encrypted to you and authenticated as being from them? So the rules for that are all embedded in Urbit. How does it know what data to store permanently? How does it know what apps you're running? How does it know how to run those apps? How those apps interact with each other? And what all the rules are for how those apps maintain their own self-consistency so that they don't end up with bugs, or end up in some sort of corrupt state. So Urbit maintains all of that, and it does it in as you'll see, a much simpler way than you might imagine. The way it does that is unusual from a computer science perspective, and it's different from the way we think of modern computers. So it takes a bit of explaining. Also, it's Urbit, we like to think of it as an overlay OS, overlay operating system, which is a sort of almost unique category. There's some old stuff from the 70s and 80s called Smalltalk images that are very similar. And you can find sort of echoes of other parts of Urbit's design, or sort of prefigurations, rather, of parts of Urbit's design in many parts of the history of computer science. It's not sort of coming out of nowhere. But in any case, it's different from what you, as a programmer or as a layperson, have probably dealt with before. So I'm going to try to explain it, explain sort of what it is, where it fits into a computer, where it fits into your life, and also where it fits into the modern computing ecosystem, and I'm going to contrast that with where we see that going eventually. So right now, Urbit is a program that you run on your computer, or you can run it on a computer that you're renting in the cloud. So, and Talon, the company I work for, has a hosting service that you can pay to run your Urbits in the cloud for you. But you can also run it yourself on your own computer or on another server that you have somewhere. So that's what Urbit is right now. And these these Urbits, these programs, it's a program that you run on an existing operating system. So we call it an overlay OS, as I mentioned, because it overlays over your existing operating system. And right now you generally access it through a web browser. So you use it mostly by interacting with it the way you would with Gmail or Facebook or anything like that. But long term, we see Urbit as being the primary thing that you run. So instead of running Mac OS or Windows or Linux, Android, right? Instead of running something like that, you'd actually run just Urbit, and that would probably have some pieces of code that run sort of inside the virtual machine, some that run outside the virtual machine. I'll describe a bit about what that means. But it is intended to be pretty much all-encompassing, and I'll go into the caveats there about what it is not designed to encompass. But very long-term, we imagine hardware, like processors, that are designed to run Nock, which is the machine code that Urbit uses. At the moment, that machine code is run by a program on Mac OS or on Linux. And we'll eventually write one of those that runs on Windows too. So long term, we see a computer primarily being something that runs Urbit. And almost all of what we've written can actually be implemented in hardware to some extent. That's a complex question about exactly what can be implemented in hardware, but certainly the primary interpreter can be, like the thing that actually runs the machine code. And big chunks of the operating system itself, the overlay OS, can also be moved into hardware itself. And eventually, Urbit will freeze. So this is an unusual kind of organizational principle that we use in Urbit, which is that the version numbers go down to 0, and then they stop. So different parts of the system have different version numbers right now. Nock, the machine code, the specification for that is at version 4. So there are 4 more versions left. 4 more times we can change it if we need to. I suspect we'll actually never change it again. I think it's probably fine. Maybe we'll change it once. We'll see. But it's fine, really. You can quibble with it, and sure enough, people do. But is it blocking anything? Is there something you can't do with Nock that you really need to do to satisfy the requirements? And there's some debate about that as well internally, but in my opinion, no, it's fine. We have other problems. Nock really isn't one of them. So the other parts of the stack are a programming language called Hoon, which compiles to Nock, and that's what the rest of the system is written in. And that is at version 140. There's a kernel, operating system kernel, which, and I'll define that again in a bit, but it's basically just the sort of core machinery of the operating system. And that's, I think, around version 250, something like that. So there are a few other version numbers, but just to give you an overall kind of feel for where the project is at, right? It's like we expect to change this operating system a couple hundred times. But not more than that. So, sometime in the next few decades, we actually expect this thing to freeze pretty much completely. Might not get all the way down to Kelvin 0, but it'll congeal down to a state where, if we're changing things, they're going to be small changes, and they're going to have a high degree of backward compatibility. So by the time we get down to low kelvins in all the major system components, at that point, you really could make a piece of hardware that implements just the Urbit operating system, or the Arvo, which is what we call it, named after Arvo Part, who's a 20th century musician. I think he's still alive, actually. But in any case, that's where we see this going. We see this whole thing freezing, and once it's frozen, then it's a great standard, right? You can implement the standard however you want, right? So then, what that would mean is that if I have, my personal Urbit, which is called a ship, by the way. So I have a ship, you have a ship, my ship communicates with your ship. So that's the piece of data that corresponds to all of my files that are inside of Urbit, all of my apps that are inside of Urbit, and all of the data that they're maintaining about what they're in the middle of doing and what they have done if they decide to remember that. All right, so that's all of the data that you need to run this Urbit and to run this ship. All the data you need to run it, and you can query it too. So you can treat it like a database and just ask it questions, to ask it what kind of data it has in there, or to ask it to calculate something for you. So all of that, that's it's a folder right now, but you can think of it like a single file if you want. It's really sort of one coherent piece of data. And so once Urbit is frozen, that means that you will be able to take that piece of data and run it using anything that implements the spec of the Urbit OS. Right? So that spec is frozen, or will be frozen. And it's relatively small in terms of complexity, defined in a particular way, meaning that right now it's about 28,000 lines of code. And that code is a full specification of how this operating system is supposed to work. And this might, if you're not a programmer, this might sound normal. It's like, yeah, okay, you have some code that specifies how something might work. But this is not how specifications are usually written in programming. Usually they're somewhat informal in the sense that they're written in human language, like English, and they describe how something is supposed to work. Are there problems with interpretation of that in practice? Like, maybe some. But with Urbit, it's actually a full formal specification in the sense that the only things that you have to rely on to interpret it are basic math. And so there's a little bit of informal description about what math you need to describe knock, really, the machine code. And then everything else is implemented in terms of that machine code. And the rules for how that machine code is evaluated, is executed. And those are formal mathematical rules. So what this means is that it's a very tight spec. There isn't really any room for interpretation. Or very little. There's a little bit in the way that the events come in and effects go out, and exactly what requirements a sort of implementation has. There's a little bit of informality there, but very little, especially compared to any other modern operating system. And that spec is small in the sense that it's not very complex. So it's only 30,000 lines of code, about 28,000 right now. Hopefully that will go bring that down a little by the time we're done, actually. And this is in contrast to the Linux kernel, which I believe is 5 million lines of code. Windows is also in the many millions. So there will be some code running outside of Urbit, but that code is not related to the spec. That'll be the code for, basically, for what's called var, which is the program that runs Urbit, not for what runs inside the operating system and how the operating system itself works. So that's like, code in Microsoft Excel, not in the Excel file that you have. Of course, our version of an Excel file includes a full extensible operating system that updates itself, sends network messages, runs other programs, compiles programs, all kinds of things. So it's a little bit of a different comparison. There's sort of much more embedded inside the operating system than there is outside of it. And so that's the other principle here, is that we want the thing that runs Urbit not to have to be that complicated. So that's also something we're working on. Also, the thing that runs Urbit can vary as long as it implements the spec correctly. So you can have many competing implementations of Urbit. Maybe some of those are actual pieces of hardware that run it like a processor. There's one of those that runs on Linux. There's another one that runs on Mac OS. Right now, those are the same thing, basically. The one that runs on Windows will probably be somewhat different because code runs a bit differently on Windows from on Mac or Linux. But however you need to implement that or want to implement it, that can be fine. Just like how Google Docs can open an Excel file, right? Excel can open an Excel file, so can Google Docs. Similarly, different Urbit interpreters, different implementations of var, should all be able to open and run to run a ship. They should all be able to run a ship. They should all be able to query it, etc. So maybe something about why do we want this thing to exist, right? Like, okay, I think I've sort of defined what this is, right? It's this file that you can run. It has a pretty tight specification for how it's supposed to update itself, and it is extensible, and it can send network messages to other instances of itself, right? To basically, I'm running my own ship that's storing my data. You're running your own ship that's storing your data, and those two ships can exchange network messages in an end-to-end encrypted way over a peer-to-peer network. And why do we think this is useful? And the way I see it is that a lot of modern computing is sort of designed in a top-down manner, what some people call centralized versus decentralized. I think those terms are a little misleading. And what's important to me is that I think it's very good for one person to be able to run their own personal computer without really depending on anybody else to do it, and for any group of friends or family or organization to be able to run their own computers and have those computers be able to communicate with each other, also without relying on any sort of third party to keep that communication going. It seems very basic to me, sort of like just in general, what do you want your computer to do for you? And yeah, I should be able to talk to my friends. I should be able to share some data around. I should be able to run some programs locally on my own machine and store that data and back it up, and then send some of that data to some of my friends. And there's a problem right now with the way that almost everything works, where that's not actually how it works. It goes through some sort of very large centralized party, usually a very large corporation. So Google, Facebook, Twitter, Dropbox, And why does it go through one of those? Because nobody's running their own server, right? So nobody is running something like an Urbit, a personal server, where it's something that actually other people can find on the network. This is a technical detail, but it's a very important one. It's not obvious because we have all these devices that and programs that seem like other people can find those devices on the network, but they can't actually. Your phone, your personal laptop, these things are generally behind. They access the internet through a router, right? Your home router or the router in your office, or the cell phone networks, towers, and those things let outbound communication go, right? So which means that my computer can send a request from my home out to Wikipedia, and Wikipedia can respond. But if Wikipedia wanted to find my computer, if my computer hadn't pinged it first, it wouldn't be able to. And so any peer-to-peer network has to solve this problem. The way Urbit does it is that you can access any number of infrastructure nodes. There are special nodes with short addresses called galaxies and stars, and they run as public servers, and they relay traffic for you. So you can set up an arrangement with one of them, and pay them a little bit of money. Actually, right now they're all running for free, but long term, you probably pay them a small monthly fee, $5 or $10 a month, something like that, like a Spotify subscription. And in return for that, they will relay packets to you. Now, they can't understand the packets. This is what end-to-end encrypted means. So this is a common misconception. They think, is when people hear about Urbit, they think, when you are running, if the packets go through a star or go through a galaxy as a relay in order to get from my ship to your ship, then that relay will be able to inspect the packets and figure out what data you're sending. But that's not how it works. End-to-end encryption means that the packets look like gibberish to the relays, except for the fact that it's being sent from my Urbit address to your Urbit address. So that's end-to-end encryption, and that's one of the sort of core principles of Urbit. And any of these stars and galaxies, if you don't like it, you can go find another one and pay them instead. And since they don't know what traffic you're sending, and your Urbit address is not tied to your real identity, they have no idea what you're sending, what you're doing with them. It's not their responsibility. It's not any of their business, and they have no way of knowing. And so it's a very sort of fungible requirement, right? So it's like, okay, yeah, you do in general need something, just at a technical level. There's sort of no way around this. You have to have some root nodes in the peer-to-peer network to perform NAT traversal, which is the technical name for this concept of, I can send packets out, but nobody can send packets in. Nobody can find me. So in order for people to find me, to be able to send a message to my Urbit ship, there does have to be something sitting there on the public internet. So in Urbit, there are 65,000 stars, 65,000 infrastructure nodes for doing relaying, and there are 256 root nodes called galaxies. So those are all. So there's a lot of variety, a lot of choice, and it's very unlikely that there will be none of these that operate correctly, right? And in fact, there are already many different parties running infrastructure nodes on the network. And so you already have a lot of choice, even though Urbit is relatively young and relatively small. So this part of the promise has already panned out pretty well. And it'll just get a lot better in the future as more people get on the network. So this explains the networking side of this, right? It's like, okay, well, yeah, it's good to have peer-to-peer networking. Urbit isn't the only thing that has peer-to-peer networking. That's been around for a long time in various forms. Bitcoin is a peer-to-peer network. Ethereum is a peer-to-peer network. BitTorrent is a peer-to-peer network. Various video protocols or something like peer-to-peer networks, right? For doing video calling, that sort of thing. So this is not a new idea, and Urbit's implementation of it is not particularly interesting. Other than the fact that it's very bare bones and stripped down, and the fact that it's not relying on goodwill on any particular party. It's relying on rational self-interest of all the parties involved. So it's in the rational self-interest of a star to provide good relaying services because they're getting paid for it. And there's very little potential for abuse. Basically, the worst thing they can do is just not be a very good star, just have a spotty service. This is in contrast to ISPs, by the way, internet service providers who are notorious for doing their damnedest to inspect packets and try to sell your data to advertisers. Daniel J. Bernstein, a famous cryptographer, has some good talks about this. Much harder to do in Urbit. Probably not possible. So, all right, so this is this idea of like, okay, we want to have a peer-to-peer network. And the reason we want to have that is so that you don't have to go through Gmail or Facebook or one of these big centralized services in order to just communicate with each other. People don't really realize this, but when you send a Gmail message or a Facebook message, if I send that to you, that doesn't just go from my phone to your phone. That goes from my phone to Facebook. Facebook has a big data center where they store what you've sent there, and they analyze it. They analyze all the text to figure out, how they can better serve you ads, among other things. And then you send a Facebook message from your phone. Facebook stores the data that you've sent, analyzes the data, and then when my phone comes online and asks, it doesn't ask your phone for data, it asks Facebook's server. Facebook server says, yeah, there's a new message for you from this other guy. So it sends that down. So, I use the analogy of modern networking is like using Ticketmaster to organize a house party. It's very different from the way that people hang out and communicate physically. Right? When people hang out, they generally just talk to each other, and then in the party they just talk to each other, right? At the house party, they're all just in the same house talking to each other, and there's no third party, listening to that and recording and analyzing behavior and predicting behavior. The fact that we're sort of used to this in the digital world is, I think, is sort of a form of learned helplessness, basically, and it's not. Maybe it's not as evil as it could be, but it's still not ideal. It's not just a privacy concern. Also, there are all kinds of other concerns that come up just because of this sort of unnatural arrangement. So, for example, Signal is a great service. They're peer-to-peer, or they're end-to-end encrypted at least. They're actually sort of not really peer-to-peer because you have to go through their servers that are run by the Signal Foundation, maybe Signal Corporation, I can't remember the name, but there's one organization that runs all those servers. And it's a nonprofit. So you better hope that it keeps getting donations and that it doesn't run afoul of any kind of anything in the United States government or some other government that sort of let it continue to exist because it's centralized. So it's a great service, but it's not necessarily something that you want to rely on forever. And maybe it'll stick around, but when it comes to communicating with my family, with my friends, I don't want to have to rely on that. And people shouldn't have to. And especially, let's say if you're running a hospital or something where it's actually mission critical or life critical, you really don't want to have to rely on third parties that could fail. So with Urbit, if you're a hospital, you might want to run your own star, or at least maybe even have some sort of contract to fail over to a different star if your normal star doesn't work right? So because in Urbit there's 65,000 stars you can choose from, and it's much more feasible to just run your own infrastructure. Okay, so I was still talking about the peer-to-peer stuff, because that's really key to this. It's like Urbit, the whole idea really is that every individual should be able to run their own personal computer with no external dependencies. So if all I want to do is just store my own documents and things like that, my Urbit should be able to run just fine when it's not connected to a network. And it should still be useful for me to just keep everything organized and have embed all the rules for how my apps talk to each other and all that different stuff. And then when it comes to networking, if I want to communicate with somebody, if I want my computer to communicate with another computer, it should be able to do that with as few other external dependencies as possible. So it needs to find some star somewhere that will relay packets for it. And there are plenty of those to choose from, and I can move that around as necessary. And then the data only goes to is only ever stored by the people who I want to store it. If I want to send a message to you, then you and I both store that message, and that's it. And if we both want to delete it, then we both delete it. So the control and the responsibility is as aligned as possible with the people who are actually engaged in whatever activity is going on, as opposed to the current world where there's some giant megalithic company that both has control and responsibility for maintaining communication among different people. So long term, this is much more sort of robust, and it's much more bottom up. People use the term decentralized, but I just really like this idea of having self-sufficient communities of people that can communicate digitally, use it from their own machines, and there isn't this sort of central overlord that everyone depends on. So it's not just the networking that's designed this way. The rest of the operating system is designed this way too. This is why it's designed as a piece of data, so that it's not dependent on what machine it's running on. Right? Like, I don't have to rely on Apple to back up my Urbit the way it backs up my iPhone, and rely on some very specific software that it uses to transfer that data from one phone to another when I buy a new one. No, in fact, Urbit should be very easily transferable. Every ship is, and this is true already, every ship is very easy to transfer from one place to another. You just copy the files, right? You shut it down, you copy the files to the new computer, you install Urbit on the new computer, you run your Urbit, you run your ship on that new computer, and all the networking stuff just works. It'll pick up, people will be able to find you at this new location on the new machine. All your other apps just work. Because it's all stuck in this file, and because the spec is so tight, basically either the whole thing works or it doesn't. More or less. You can still have bugs, but but that interface between the Urbit and the external world is very simple. There are 5 different channels for communication. It persists data and stores permanent data in one very particular way. The machine code is 11 opcodes as compared to normal x86 64 machine code, which has somewhere between 1,300 and 4,000 opcodes, depending on how you count. No one even really knows. I mean, people know, but it's hard to count. There are tons of them. It's very difficult to really have a tight spec there. Processors, of course, are notorious for having loose specs these days, which is part of why there's so many security vulnerabilities at the level of the processor. Things like Meltdown and Spectre, and the recent SGX attack, right? So actually, a NOC processor for running Urbit could be much more tightly specified and have a lot fewer opportunities for security vulnerabilities. Urbit in general, its design actually greatly facilitates security, because that's one of the major things that you want from your own personal server, your own personal digital archive, is you want for it to be secure. So we use state-of-the-art cryptography, and the number of places in the code where we're dealing with external data, those are the places that are typically unsafe. Right, that's a large part of where you'll typically find security vulnerabilities, and that's locked down to 5 different channels, each of which has the same way of converting external data to internal data, and so there's sort of one function really for ingesting external data. That function is maybe 500 lines of C code, and easily auditable. So there's a sort of a unified model of how data comes in, and that unified model makes it so you really only have to lock down that one function. So to be clear, Urbit has not been hardened for security just yet. It's quite likely that at the moment there's still some security bugs, but like any system, it needs to be hardened in order to really withstand a real-world attack. But the amount of work required to do that in Urbit should be much less than the amount of work required for many other systems. We can also keep our crypto upgraded. We have ways of upgrading our network protocols on the fly. And when we do that, we can also upgrade the cryptography used, so that if the crypto we're using now turns out to have a vulnerability, we can upgrade that as well. So from a security perspective, it's designed to be self-sufficient. This is actually one of the hardest things about trying to run your own server these days, just on the normal internet, is you normally have to run so many different programs that each have their own security model, that you have to keep all of them up to date. And if you fail to do that, then random packets coming in off the internet will take over your machine. Your machine will become part of a botnet. And so, again, unifying all that down to here's how you ingest data. It's just one function. All you have to do is get that right. All your different apps will share that. Much easier to keep secure. So, this is sort of the overall. These are sort of the overall goals of Urbit, right? That you have this, what we call a solid state interpreter long term. Right? You have this thing where, in order to run it, keep it secure, keep it up to date, keep all of its data stored, maintain its availability on the network, maintain its connections to other people, keep it encrypted, keep it peer-to-peer. To do all that, all you need is this one program, var, the Urbit runtime, that you can run on any other operating system, and that manages this one folder that stores all of your stuff, and if you want to switch from machine to machine, you just copy that folder over, run it on the new machine. And that thing keeps itself up to date, maintains its own security, maintains all of its own invariants, right? All of the rules that it's supposed to, keep enforced. It enforces all that for itself. You can install apps into that from inside of it. It's extensible. And so it's a way of sort of abstracting over which machine you're running on, what sort of low-level software is running on that machine, where that machine is physically, where it is on the IP network that everything runs on top of for the internet. All of these things have been abstracted away, and what's left is the set of rules for how you want your computer to behave, and how you want it to communicate with other computers. So that set of rules is embedded in your ship, and you can move that around, and it's completely yours. There's no external dependency. If you don't want to put it on, if you don't want to use the network at all, you don't have to. And if you only want to communicate with just your family, you can, or just your family and friends, or everybody. It's all up to you. So this is really all of the design decisions in Urbit are geared toward making it so that you as an individual have as much control over your personal computing as possible. Really, bring the personal back into personal computing, right? And then when you want to do networking, when you want to have a community or an organization with whom you want to communicate, that community or organization should be as autonomous as possible and not have as few external dependencies as possible. And of course, all of these things are sharing the same network, so anybody can talk to anybody if they really want to. But this is instead of having one or a very small number of large centralized corporations that intermediate all communication. So Urbit is really sort of an alternative vision to that. And this is the vision that got people excited about the internet in the late 80s, early 90s, right? This is what people wanted. They wanted this sort of bottom-up, decentralized world. People don't really know this, or some people do, but it's not wide knowledge really that email was originally a decentralized protocol. The idea was that you would run your own email server, and then those servers would communicate. So I could run my own email server, you'd run yours, those could send, and then email was this protocol that would allow those two servers to communicate with each other. These days, if you try to run your own email server, it's very difficult because things like Gmail will actually filter you out. They'll assume that you're a spammer. Because what ended up happening was that these systems, these early internet systems, just weren't designed to handle billions of people. Some of whom are spammers, some of whom are, trying to steal your identity, steal money from you, some of whom are just trying to deny service to you through denial of service attacks. Still others are just trying to take over your computer. Some others are trying to, snoop on you, to turn over data to advertisers. And just in general, the networks that we have really weren't designed to handle bad actors on the network. This goes all the way back to the early designs of IP and TCP, these foundational protocols of how all this stuff works. They have no concept of authentication, encryption, right? There's no concept of identity or the idea that you might actually want to have private communication, or that you might want to ensure that if you hear a packet from your friend, that you actually can verify cryptographically that it did come from your friend. So that stuff all had to be grafted on later with varying levels of success at different layers of the stack. And so this is part of why email never really worked out as a decentralized protocol is because you actually needed to filter out a lot of the spam. And so you ended up with Gmail and a couple of other big companies aggregating enough data that they could actually effectively do that, right? I mean, they do keep the spam pretty decently under control these days. But the reason that works is that, it's really just we're all connecting to Google's mainframe to use Gmail, as opposed to each of us running our own server. And so the email protocol is not really used anymore, or only in very limited ways. And this isn't just a problem with email, this is a problem across the board. And it turns out that to solve this problem, you have to go all the way down to the basic networking protocols, the basic concepts of identity, and also the basic ways that your operating system works. Because even if you get all the identity stuff right, you can imagine, right, running something else that uses your Urbit ID, right? That's not running the Urbit executable, which is this, bizarre thing from another century, another planet, or whatever, right? It's unusual, and it's new and not done and somewhat buggy. And why would you use that? Why don't you just use normal technologies, right? Why don't you just use Linux? Why don't you just use Mac OS? Why don't you just use Docker? Why don't you just use X, right? And really the reason is that those systems, none of them were designed for this purpose of having this system that you can move from machine to machine that's simple enough and secure enough that it can be extended and managed and kept secure by one person who isn't technical, right? This isn't for programmers. I mean, it is also for programmers, but this is for everybody. Urbit is for everyone, full stop. And that means that you need to be able to run it without being a system administrator. So this has to actually be designed with such simplicity and security that it can keep itself secure, it can keep itself functioning without you, as the proprietor of this thing, having to intervene all the time and fix it when it breaks and keep it running and keep it up to date. It should do all that stuff for you. And in order for it to actually do all that stuff for you, it has to be designed in this much simpler way, where it maintains its own rules, it enforces its own rules, it's tightly specified, and it's a standard, right? And in fact, I'll do another talk on the internal design of the machine code, the programming language, the operating system kernel, the kernel modules, the networking system, the application runner, and the I/O channels, input-output channels that it has, right? The protocol that is the event effect protocol for communicating between inside Arvo and outside of Arvo. So I'll do some more talks on those, and you'll see that this thread is going to run through all of them, right? That this thing needs to be done in such a way that it keeps itself sort of intact as you move it from device to device, and as it updates over time, and as it installs new apps, and all of these things. And so there's a ruthless simplicity, a ruthless minimalism that we apply all throughout the stack. And this is why it ends up looking so different from everything else in modern computing, is that we use a different set of components to implement all this stuff. And by layering the system the way that we have, we actually make it possible to achieve all these goals that we've set up. So that's the basics. Tune in for the next episode to hear about some more of the internal design of the system.